All right, scholars, we are now moving on to IB style questions for compound interest and also compound depreciation. Here are two formulas that we're going to use. The only thing different between them is for compound interest, we're adding. For compound depreciation, we're subtracting. Interest increases, depreciation decreases. So you can think of subtraction. The variables still stay the same. We're just going to dive right into one of the IB style questions. Now, what makes this different than the word problems that we were dealing with in the last module? Well, IB questions, remember, have multiple components. So instead of looking for just one thing, we're going to be looking for multiple things. And sometimes those components build off of each other. So if we took a look at this, Maya deposits $4,000 into the bank account. So that's the initial amount. The bank pays a nominal annual interest rate of 6%, compounded quarterly. So in part A, we need to find the amount in Maya's bank account after 5 years, round to 2 decimal places. In part B, we need to find the amount of interest that Maya will earn over the next 5 years. Now, the big thing that we have not talked about, but I do want to emphasize, is interest. We're not looking for the interest rate. So we're not finding R. We're finding the additional amount that was added to her account. Okay, remember, she initially put $4,000. That money is going to grow, right? And that growth is going to be interest that is added to the $4,000. And that's what we're going to try to find for part B. But let's figure out first how much money is going to be in her bank account after 5 years. So I like to make this table whenever I'm dealing with compound interest, compound depreciation, and when we go further on financial math, I use the table. It's just a way to organize my thoughts and the variables. We're looking for the final value after how many years? 5, where she initially put in $4,000 with the annual interest rate of 6%. Again, that comes from the problem right here. And we know that K is 4 because it's compounded quarterly. So I use the formula. I plug in everything, grab my calculator, put the 4,000 plus the fraction, the 6% annual interest rate, divided by 100 times by the quarterly compounding action, raised to the power of 4 times 5 years. And I get that value, which is really close to, when I round to 2 significant figures. Again, I'm looking at the decimal, going 2 places afterwards. This is the second decimal place. Look to the number right. That 2 is going to stay the same. So roughly, she's going to have $5,387.42 in her account after 5 years. Okay. The next part is we're trying to find the amount of interest that she earned over those 5 years. So the big thing, interest is the additive amount that was was put in or added since the initial deposit. So the simple way of getting it is you take the final value minus the starting amount, right? This is how much money she had after 5 years. This is what she initially put in there. So what is the difference? That's the additive part, the interest that was put onto it. So if we look and do the calculator, we do 5,387.42. That's the final value minus how much was initially put in there, $4,000. And we get that the interest, the additive amount of money that was put into the account based on the interest, is $1,387.42. Okay. So interest takes the final value minus the starting value. You can find out, again, essentially the change. What amount was added to the initial deposit? Okay, guys. Again, you have all these tools that you need now to answer these IB style questions. Take some time, dissect them, figure out what you're looking for. Okay. Are you looking for FV? Are you looking for PV? Are you looking for R? Or are you looking for N? That's going to pretty much be the building blocks you're going to need to answer these questions. If you have any questions, reach out to me. Otherwise, I'll see you in the next video. Good luck, guys.